In this station, what we're going to do is we're actually going to burn a piece of magnesium ribbon. And in order to do that, well, we need a couple of things. Well, first off, safety goggles for all these stations. A must. I'm going to be looking out for that when you guys are working on the lab, and so will your lab teacher if you're not actually in one of my classes. Anyhow, what we're going to be using here is what magnesium ribbon looks like. Right? It's just coiled up. And what we're going to do is we're going to just cut off just a little piece just like that. I'm going to actually have it probably pre-cut for you. Just use one, please, because this stuff really a lot of students love to try to burn through it. We're going to be using the Bunsen burner. So I do have a video on how to light a Bunsen burner, but I'm just going to kind of do a quick little demo on how to light the Bunsen burner. So what we do is we're going to open up the gas valve. We're going to let gas go through it, and what we're going to do, light the Bunsen burner. And there we have it. And what we want to do is we want to be able to get a blue flame. So we've got controls to the amount of gas coming through from the bottom here or from this valve. We can control the amount of oxygen through this little air inlet that controls the amount of oxygen to allow for greater combustion, or so-called the complete combustion, where we're letting lots and lots of oxygen. If you don't light the Bunsen burner, one thing to make note of, after about 20 seconds, even 15 seconds of not being able to light it, please turn this off. You don't want the gas stinking up the room. I've had students get nauseous from the smell of the gas. Anyhow, for safety, what you're going to do is, here we've got these metal tongs. You're going to hold with the metal tongs your piece of magnesium ribbon, and you're going to burn it. And preferably try to hold the piece of magnesium towards that inner blue flame. And that's what we're going to do. And what we're going to do is actually, I'm going to demo this demonstration. You're going to tell me in the lab report what kind of reaction occurs and what forms. So we have a silver metallic piece of metal, of magnesium metal, and we are going to burn it. So be careful also, it gives off quite the color, quite the light, so do not look directly at the flame. So here we go. Note the color of the magnesium. Okay. And once you are done, carefully discard it onto this little piece of glass. And once you're done, turn off the gas. Make sure your area is tidied and move on to the next station. This station here, again, not the most exciting. Really, the whole premise of this one is to demonstrate the actual burning of the gas within this Bunsen burner. And really for show, just to show that it is considered what kind of a reaction, right? It's going to be heating water. That's all we have in this beaker. So in this station, we're going to be heating the water. And in the write-up, you're going to be discussing really and telling me in a balanced chemical equation what is the formula of the reaction that's taking place. So again, safety reasons, because we are using a Bunsen burner, safety goggles a must, hair tied back. So we're going to turn on the gas. You're going to hear the hissing sound. Light the Bunsen burner. Okay, notice here, quite the flame, right? Very uncontrollable. So what we're going to want to do is we're going to want to control the amount of gas that's going through as well as the amount of oxygen. We want to try to get a blue flame. And pretty much just hold it right underneath here. Observe your observations, but make note of what is so special about the end result of this reaction when we are burning or heating water. In this station here, what we're going to be using is calcium metal. just little pieces of calcium with a beaker of water. Again, safety goggles a must. Another thing that we're going to be using is litmus paper. And if you remember, when we're talking about acids and bases, hint, hint, what we use litmus paper for. And the paper that we're actually using is red litmus paper. Red litmus paper will stay red in an acid. Red litmus paper will turn blue in a base. Right? So what we want to do is we're going to take the pieces of calcium, take a piece of calcium here, and we're going to drop it into this beaker of water. I'm going to put another one there to see the show. And if you look really, really closely, you're going to see it's effervescing, right? So really it's giving off bubbles, right? So bubbles, right? And please don't give me the answer that it's giving off bubbles, because in fact bubbles in chemistry refer to gases. So you're going to tell me what is the gas that is being given off. And secondly, once you've identified the type of reaction and written out a balanced chemical equation, you are going to take a piece of red litmus paper, you're going to dip it in here, and observe, will the red litmus paper stay red, which means we have an acid we're forming, but if this red litmus paper turns blue, we actually will have a base. I'm not going to do it, you're going to do it, so good luck with your results. Station here, again, goggles are a must. What we have here is we've got copper 2 sulfate. So we've got the copper 2 sulfate and we've got iron nails. So all you're going to do with this station, grab one of the clean iron nails and dip it into the beaker of copper 2 sulfate. Let it sit for a while, make your observations, and identify what type of reaction has taken place, how do you know that a reaction has taken place, and write out a balanced chemical equation. In this station, we're going to have two beakers, one of sodium hydroxide, another one of sulfuric acid. Again, be careful. Make sure you've got your safety goggles. Be careful because both are very corrosive. We have diluted them, so they're not really in any great danger. But again, they can be irritating if you were to spill it. So again, just be careful when you're using these beakers. We've got one more beaker here. Again, it may come in beaker form. It might come as a little vial of phenolphthalein. And then for those who understand what phenolphthalein is an indicator. It indicates if something is an acid or a base. Right? So in this demonstration, what we're going to be doing is, just like with the other stations, we're going to do 3 eyedroppers full here of each chemical. So we've got sodium hydroxide. So in this one, I'm going to put... So I've got sodium hydroxide in one. Let me put one more. So 3 eyedroppers full of sodium hydroxide. What we're going to do is we're going to do 3 eyedroppers full of sulfuric acid. Right? And we already know which one is an acid or a base. But the one thing what we want to do is we want to identify in this one, what does an indicator, or how does an indicator like phenolphthalein indicate acids and bases? So I'm actually going to show you this demo. So what we have here is we've got the sodium hydroxide and we've got the sulfuric acid. Right? So this was the first beaker that I filled up. This has the base. This has the acid. What we're going to do is we're going to take a drop or 2, and that's all you need, a drop or 2 of phenolphthalein, like just tiny little drops, into each acid or a base. So we're going to drop 1 at 2 drops. Okay, we're going to shake it up and make your observation. So in an acid, that's what phenolphthalein will indicate. When we put it into a base, into yet another clear and colorless liquid, watch this one carefully. 1. And that's all we really need, because that's really the color that we want. We stir that up, Right? Notice that fuchsia, magenta, whatever color you want to, pink, my students like to call it. So notice there how phenolphthalein indicates in acids or in bases. In a base, as we have here with the sodium hydroxide, there's the color. But now, one of the things that I really love about the end of this experiment, I always tell students is pick one or the other and pour one into the other. And I tell them, choose the base, pour it into the acid, or the acid into the base. Doesn't really matter. I'm actually going to pour the base into the acid and watch this observation. Take a look at what is going to happen. We stir it up and notice we remove the color. So tell me, what kind of a reaction has just occurred when I poured both of them out? So write out a balanced chemical equation and tell me, has a reaction taken place, and if so, what is the evidence? Okay, so in this station you're going to have two beakers of one with calcium chloride, the other one with potassium carbonate. You're also going to have two test tubes with your test tube wrap. What I want you to do is, I want you to take 3 eyedroppers full of potassium carbonate and place it into one beaker. You take the other beaker and you're going to put in 3 full eyedroppers of calcium chloride. I'm only going to do 1. Right, but you're going to do 3. You're going to do that 3 times in each one of the test tubes. And once you have done that, you're going to take either one of the 2 test tubes, pour one into the other, let it sit for a while, stir it up a little bit. Again, goggles on, and make your observations as to what type of reaction has taken place. And how do you know that a reaction has taken place if a reaction does in fact take place?